My name is Brian Beres. I'm a research scientist with Agriculture Canada here at the Lethbridge Research and Development Center. And my role is agronomy, and I tend to do quite a bit of cereal-based agronomy, with half of that being winter wheat agronomy and the other half spring wheat, but also obviously taking a systems approach to things. And so when we talked about today, Ken was like, "Oh, are you going to talk about winter wheat?" And I was like, "Well, given the date and kind of the temperature, I'm not sure I'm going to have any left." And I've actually had to hold Stephen off, actually. Otherwise, that winter wheat back there would be gone. So I decided this is kind of an interesting study that we started a few years ago that the Alberta Wheat Commission is funding, as well as Alberta Innovates Biosolutions and the Western Grains Research Foundation. And the thing that inspired me about this study, I grew up here, actually just straight east of the research center on a farm in what's called Ready Made. And we were irrigated farmers, but we had cousins out in Fort Macleod that were dryland. And I grew up in the time during the mid-'80s when it was pretty tough going here, particularly for dryland farmers. And so I've always had an appreciation for wheat production in semi-arid systems, and how we can buffer and make that production system more stable over space and time. And this particular study, I was going down to speak at a sawfly conference in Bozeman, Montana in around 2011-12. And it was the end of March, mid-March maybe. And when you got down into Montana, guys were already rolling. And really what the thought was at the time, or at least growing up, was like, there was quite a bit of risk in planting your wheat too early, because it could just sit there and rot, or, predation, injury from cold, whatnot. And so that kind of inspired me to think about something like that. And the other thing was that Rob Graff I had been talking about these what we call cold tolerant wheat lines, which is what you see here, these ones that are awned. And it was interesting. Basically what they are is they're winter wheats with the vernalization requirement bred out of them, so that Rob could increase his cycles and move traits in and out of this, so that without a winter nursery he could still make as much progress as possible with advancing lines and that sort of thing. So that was kind of the inspiration for this. The other thing that was happening at the same time is I was working with some engineers with Alberta Agriculture, trying to develop a smaller scale no-till drill, using some equipment that we had left over from our Conservapac drills. And so that's kind of a work in progress, and you'll see some misses and some missing rows here. And the reason you see it in this trial is this is the first trial of the year that we get going, and we're only in year 2 of these 2 prototypes. So we've had some issues that we've had to work out. So instead of trying to hide it, you'll see it for yourself. But it's been a really neat project. And so the idea was, well, let's try and work with these cold tolerant lines. And rather than wait to the recommended time, and then I say time because if you read a lot of papers, recommendations, it's always a planting date, which is an arbitrary observation in time that we can never repeat with respect to the type of conditions that occurred on that date in that year at that location. And so really sort of an underlying theme of this is using soil temperature to drive decision making around when to go in. And the hypothesis that ultra early seeding would be, if not beneficial, would reap you the same benefits as going in at a recommended date. And as far as soil temperatures go, you would probably read in some of the recommendations, well, in the top 5 centimeters, it should probably be at least 10 degrees before you get rolling. So that became our last time that we would go in with this study, but we would start at 0 degrees. So in the top 5 with Ryan, where's that soil probe? Just a very simple soil probe like that, just stick it in, top 5 centimeters, and as soon as we hit 0 degrees, that's the trigger point to get the study rolling. So that's what the guys would do. So that trigger would vary quite a lot. So the trigger for 2 years ago was March 6th. The trigger last year was February 16th. If you recall, we had a very mild winter. And then we had a little bit challenging one this year. maybe a little more normal, and then followed by some pretty stressful conditions that we've already talked about, and that was, what was it, March 20th. So you can see what that means by a planting date. What does a planting date mean? Well, we've jumped around by within a 6-week window practically of when that date should be. So it should be the soil temp driving it, and so some quick observations, some dates. We used a few lines that we selected from Rob's material, kept 2 of them, compared that primarily to Staedtler to see if you need cold tolerance to go in that early, and if it's actually something that would work. And the first plot you see over there is notable because the drill that we were using is this one here. If you're familiar with Conservapack drills, you'll know that they are fairly aggressive, and so the ground was frozen at 0 this year, and so it was ripping up some pretty big aggregates and not giving us very good seed to soil contact. And I think if we were to try it, say with this drill here that's got the pillar laser openers, we may have had a little bit more success. If you've heard or read about frost seeding that they sometimes do or advocate down east, that's what they'll do. They'll go in late fall, winter, and actually go on frozen ground using a disc drill because they can still get the penetration that's needed. So in 2-degree increments, we basically started planting 0, 2, 4, 6, 8 to 10 degrees. And the data to date, we're still not sure what we're seeing as far as a utility or need for cold tolerant lines, because Staedtler is actually doing quite well. You'll see though as you walk down the range that these actually look like really good lines, and yield wise they're out yielding the CWRS checks that we have in Staedtler and Conquer. But that's a function of the plant type. If you had to pigeonhole this prototype line into something, it would probably be more like a CPS or that DNS in the States or whatever. So it's a high yielding, slightly lower quality that you would expect to out yield a Staedtler, for example. And so it's too early to tell. We've got a PhD student out of the University of Alberta, co-supervised by myself and Dean Spanner, and he's going to be looking into that whole background of the photo period and the vernalization genes and how those responses vary. There's some experiments back there that Mr. Graham Collier has as part of that, including these ones. So we're asking a lot of questions and getting some pretty unique responses. And so after 2 years of data, basically what we're finding is that you can go in very early, starting at 2 degrees and not suffer any yield penalty. In fact, it's the opposite. You would, in some cases, start seeing a yield drag already after 2 degrees, which is totally counterintuitive to what the recommendations are to date. And so we'll see what this yields this year. So we've got this located here, Scott, Saskatchewan, and as far north as Beaver Lodge or Dawson Creek, just to test it in a range of environments as well. And the Alberta Wheat Commission has stepped up to fund the second phase of experiments that Graham's going to be looking at, because if we say that going in really early or ultra early is something we would advocate, that may require, some tweaks to the agronomic system with respect to weed management, when and where to place that nitrogen, that sort of thing. And so Graham's got some studies going on that. We can walk down here and I'll show you the experiment further down, where we then took these lines. Now that we know that ultra early seems to be something that's tolerable and maybe even something we would recommend, how does it change with these lines with respect to seeding rates and as far as the depth? So do you seed shallow? We know with spring wheat, unlike winter wheat, we would tell growers for winter wheat, don't seed down to moisture, stay within that top inch or less. What do you do with spring wheat? Do you chase moisture? And to what degree do you chase moisture? So you'll see we've got some plots down there where we're going either 1 inch deep or 2 inches deep. And that makes quite a difference depending on the seeding rate and obviously when we go in. So we'll just maybe go for a walk. So there's a question about, do we know the range of tolerance to cold of some of these spring wheat lines that are registered in the CWRS class? And I don't believe we do. So as far as consistency, stability, and whatnot, basically the range is the highest consistent yield over the locations that we have has been in the range of 2 degrees to 6 degrees. 8 and 10 starts to get a little bit late, and you'll see down, I think I lost my, is it still going? Oh yeah. The canopy actually on these later seeded ones this year, probably in relation to what we've seen for weather and precipitation, doesn't look too bad, but if you look closely, I'm not so sure how they're going to fill out relative to something that's already almost ready to combine. So that would be a concern. And so this is the experiment here where we're looking at, again, going in increments of soil temperature, but using a low plant population, which is a seeding rate of 200 seeds per square meter versus 400. And we had quite a conversation in Lacombe a few weeks ago about seeding rates of spring wheat. And there was 1 or 2 people there that thought that 400 to 450 seeds per square meter would be something they would never recommend in central Alberta. I'm not sure why that is, because we have data that really, under very stressful conditions, have shown that, particularly with high yielding varieties like or a class like Durham, you almost need that 450 seed rate to get up to actually reach your optimum yields. And it's kind of like the corn hybrid example where we had no response to the hybrids once they were developed until we started pushing seeding rates. And I think that same principle would apply to winter wheat, spring wheat. As our breeders are making progress with genetic gain, in order to capitalize that on farm, we've got to change our management. One of the easiest ones to do is through seeding rate. And we might actually, gain something by coupling that with when we go in and how we think about what's timely as far as soil temp as a trigger to go in. And it'll vary. So this plot here was closer to what the fellows in central Alberta were saying for a seeding rate. They like the 200 better than the 400. And this one we've gone down 2 inches to chase moisture. And we also went in at more of a recommended time. So 10 degrees, for example, in the top 2 inches this year, our top 5 centimeters was April 22nd, which still sounds quite early. But I think I would maybe take this one over it, which is the same line, but we've gone in really in a range of 0 to 3 degrees instead in that top 5 centimeters. Pushed it to 400 seeds per square meter. And I think you see a noticeable difference. I'm not too confident how well that's going to fill out in relation to something like this. Claire?
I think with the advent of Fusarium head blight moving north into central, seriously moving north, and other issues in pitch, we're going to need to increase to get fewer tillers anyways. So it kind of goes hand in hand with the fine.
Yeah, and that's kind of one of the other things that I've kind of been focusing on lately is the importance of uniformity, not just for the advantages that gives you at harvest. So you get a shorter canopy, a more uniform canopy, more main stems in the field, but that also shortens down your flowering time, which would have been really helpful this year. Whether you're talking about fusarium, drought, whatever. So there's just a lot of good reasons and a lot of benefits that flow from those very simple management practices, yet sometimes getting widespread adoption is a mindset that takes a while to overcome.
The other thing I want to say too, Brian, is up in the northern part of the province, seeding early has been going on for quite a while. So it seems to work up there too. You get in there when it's 2 degrees and it works just fine. So I mean, we're just kind of proving that
Yeah.
as well.
Yeah, and I mean down here it's a bit of a no-brainer with some guys, but in some ways it's like, there's a mindset of flow of which phases I want to be focusing on at which time of the year. And so that might require a bit of a rethink, not just when you go in with wheat, but in what order of your crop rotation it should appear. And so that's, we're hoping to do a little bit of sequence work on top of that of, perhaps what are some other options in relation to sequence instead of, some traditional things like canola, wheat, peas, and that sort of thing.
But the strike weevil attacking our canola early, we should be planting wheat first anyways. Wait for strike weevil. So, anyway, just
Jamie.
Can you comment about seed treatments at all with this?
Oh, thanks. Yeah. So we built on some knowledge that we had developed a few years earlier in relation to seed treatments. And it's a good question because, again, growing up here, very dry environment like this year, somebody asked me early in my career what I thought of seed treatments for southern Alberta. And I said I didn't think a whole lot of them. If you're strictly talking about control of a biotic stress. And I think a year like this year would back me up. But then we did some work on it and found that really, to me, the bigger advantage and more consistent response you get from seed treatments, whether it be winter wheat or spring wheat, is the response and the protection against abiotic stress, which is something we never ever thought about 15, 20 years ago. And so what we did is we were like, okay, we know this is going to endure and have to sustain through more abiotic stress in relation to cold and whatnot. I mean, some of these plots got snowed on quite heavily and so on. And so everything received a seed treatment of Raxil Pro. So not the insecticide, which I kind of like that neonic for what it does with respect to abiotic stress. But who knows where that's going. So we went with Raxil Pro, I believe, which gives you two fungicides that do have some benefit purported in relation to frost tolerance.
If you're pushing the 450 population and you're looking at seed treatment, that adds to the cost per unit, right? Now the Australians I understand they're doing in-furrow seed treatment. If we go to a higher plant population, can we keep our expenses down some other way?
I think at the end of the day you would have to pencil out what the inputs cost in relation to what you got back. And the economic analysis that we did with the winter wheat, which pays less than some of our CWS classes and CPS classes, the seed treatments always paid for themselves. You could say, well, and we've observed this, that the seed treatments actually give you greater plant stands than not using a seed treatment in winter wheat and spring wheat. So I'll cheat back my seeding rate to 200 or whatever and bank on the compensation coming from the seed treatment. The problem with that over time, and we've shown this, is that you move from a quadrant of high yield, high stability over time, and you start moving over to, you maintain your yields not too bad, but now your stability of the system starts to bounce around too much. And so you're going to get surprised from time to time. And not only that, I think our young new weed scientist in the back there, Mr. Charles Geddes, would probably tell us that the weed seed bank from low plant populations would do this over time as well. So I think you got to kind of balance that with and a little bit higher input on seed costs, seed treatment, but I may be going in more than one time for herbicide control at times.
And you also lose the fusarium head blade and all that stuff.
Yeah, it goes back to that uniformity thing as well, which is huge. Yes, Haley.
You mentioned insecticides. Do you have wireworm pressure on these plots or any of the other ones? Because I'm really interested in soil temperature and wireworm depth.
Well, do we? Because you're the entomologist, I would expect you all over the countryside as our new entomologist telling us. We haven't checked. I mean, we've sometimes seen wireworm pressure, and then we go and set the traps for you guys or somebody else, and then they mysteriously run away, and so that's. Well, I think you should. It's something that is worthy of investigation, and somebody beside you has a lot of expertise on the industry side of management through chemistry. So Monica, right beside you, could help you out quite a lot. Yeah.
I think we're gonna wrap it up. Oh, sorry. Go ahead. One more.
Yeah. Are you doing any work with increased rates with seed?
Oh, that's a good question. So, yep. Basically, to date, the question is: Are you playing with label rates with respect to dose of the seed treatment? And the answer would be no. And I don't. Do you have anything to add to that, Monica? Because Monica was actually very instrumental in helping us with that seed treatment study in her previous life, and I know the doses we pretty much stuck with label rates, but that's come up before. Kelly and I talked about that a bit, and thought that the gain versus what we might encounter as far as blowback to playing with label rates may not be the best.
Yeah. You have to look at what a seed treatment is designed to do. A seed treatment is designed to work on seed and seedling diseases. End of story. And when you increase the dose, you don't necessarily get longer activity. You've just spent more money. So staying at that label rate is very important. The one thing I can tell you is application is so important. If the seed treatment isn't on the seed, and there is no seed-to-seed transfer or anything.
That means you have to stop talking now. Sorry.
So, but apply it well at label rate.
Okay, well, I've sufficiently used my 20 minutes and 22 seconds, so thanks for your attention, and I got to call that bus back here because I wanted him to actually park here, but